Okay, welcome to this session for ShopTurn Programming. We want to create a simple program and explain the meaning of ShopTurn. So basically we have a simple part which has a diameter of 70 with a maximum length of 80. So we want to create a program using ShopTurn. That is a step turning. So let's go on one by one. But for you to understand all these machine control functions, you need to come to a session or our class will guide you on how to understand this. So basically let's go to program, that is program manager. Since the NC location or the drive has small memory, so we're going to use a local drive. I'm going to create a folder here, so a directory. So click on new, then change to directory. Here let's see as register it as precision as our folder. Accept, and then in this folder we want to create a new program, so click on new, then change to ShopTurn. So we are using ShopTurn. Then you have Cycle. That different way of writing a program. For Cycle you are using .mpf, but for ShopTurn we are using what we call ShopTurn way of programming. So let's go one by one. So here we can write edit name, let's say step turning, let's say, or test one for example. Accept, and then in this step test one, let's see the graphical how it look like. I'm using G54. Then here my stock, because I have a final diameter of 70, which means I need to have a diameter 80, and then I want to do a facing of 0.5. Then my length is 150, which is okay. Then from the this total length of my stock, as you can see from the graphic, then this is the length where I'm climbing up to the jaws. So because I have a minus 80, which I can put it minus 100, is okay. Minus 100 is okay. Minus 100. Then we use, because it's only turning, there's no boring, we are using symbol. There are two ways. You have symbol and extended. Because I'm only doing turning, there's no internal turning, I'm doing external turning, I'm using symbol. Then here I can do increment of 10. Also increment of 10, and then I want to tell the machine that where am I going to change the tool. So the tool point change, or where the tool can go and change. So you just click on teach, you can pick the value of the teach. Then you're using down cut, then you accept. From this accept, now we want to do facing, because already in this program header we had put 0.5 for facing. So what do? We go to now turning, and then click on stock removal. Change this. You have these two kind. We have longitudinal and face. So you change to face. Then pick the tool for facing. For example, first of all you need to get a tool, but this one have a jump, so I want to use this tool. Facing tool, I'm going to use 125. This 150, which is okay. I can even use 120. Facing. Then diameter is 80 for my stock. I'm facing 0.5. I want to exit to minus 1, minus 2 is okay, minus 1.8 is okay. Then each pass I want to cut to 0.25 or even 0.2 is okay. Then I accept. For you to understand that we are using ShopTurn, you look at how the header is. I can come to here, edit, and then I expand this, and then say renumber, and then accept. You can look at the program. So the program number 10, the sequence number 10, or that is line number 10, line number 20. This is the program header, which has the stock, material, and amount of facing, and also the work offset. So, and also where you are going to change the tool. Then here let's check, or doing what we call simulation, to check if the tool will be cutting the right way as we had projected it to cut. So let's see. For facing, I can zoom. You see there are two passes. Now we have done facing. We want to create a G code. You see, for ISO code we put the points, point to point. Same way it can happen here, but because it's ShopTurn, let's go to now contour. I want to go to contour. Also you can use a normal way, straight turn, or a G code. For example, you can use a G code, but this you use ShopTurn first of all, then I'll show you how to use a G code. So come to contour, then click on new contour. You pick, like, say the first contour 1. Then here we want to start our starting point. Having a diameter of 36 with a radius of 3. So I put here diameter 36. Then I change radius 3. Ensure this arrow is pointing up. Then click input to accept. Then from there we are going to horizontal. From this horizontal I'm going to minus 15. Accept. I don't have a radius, but because where the tool is cutting, I can put a radius of 0.5 depending on the tool I'm going to use. Let me put 0.8. Yes, 0.8. Okay, and then from there we go to vertical. A vertical, I have a diameter of 50 with a chamfer of 3, so I can put chamfer of 3. Then accept. You see on the graphic area is sketching. From there I go to horizontal. I want to go to Z minus 45. I'm putting negative because I'm going towards the chuck, and then I can put a radius of 0.8. Let me put a radius of 0.8. Accept. From there I'll go to vertical. I say I'm doing a simple step turning, so I go to now diameter 70 with a chamfer. I'm having a radius of 3. Accept. Then from there I'm going to horizontal, where Z is, so I have Z minus 70 because of facing not facing parting off. I want to put 7 minus 75. There's no chamfer, and then I exit now to 80 to tell that my stock is 80. So this is the contour. You were doing an open contour. You can also close it, but there's no need of us closing this because we want to use just open contour to create the program. So accept, and then now under this one, click on new, pick the tool, change this one as okay. We are now using zero turning, and sure this is okay. Then because we don't have undercut, just put undercut no. Then the stock diameter is 80. 0.3 is 3, okay. Then accept. If you want to do finishing, click on edit and then back and then copy, paste, then try to edit inside here. Change from this one to finish. Then you can pick a small tool, for example finish tool. Accept. For finishing I can put 0.1, then I can put here 180, okay, and then accept. Now let's do a simulation. If you click on simulation, now you will see our passes. Simple way of creating a program. You see the passes as it cuts. So this is what we call ShopTurn. As you see what's now doing after facing it does rough turning. From rough turning does finishing. Let's improve the program. We include grooving contour. Let's go to grooving, and then we take the tool for grooving. I want to put a straight groove or a chamfer groove. Let's put a chamfer groove at a length of, let's say, the diameter for this is 50. Where I want to put the groove, I want to put to minus 20, for example. If you want to see, click on the graphic area, you'll see where the drawing is. I want to put 1, not 2, 1. And then this one on minus 50, I can increase, not 50. This one should be 50, so I can put where is it, starting point, I can put minus 12 or 15. As you can see where it's sketching, then diameter here I can change where my X is. So this is X reference point for X, as I say diameter 50, and then as you can see diameter 50 where it is. So this value we can change the value to minus, let's say 30. You can see how it changes. You see how it changes, yes. And then it is 6. I'm going to absolute 50. I can put 40, okay. I want to put a chamfer of 1 by 1, that's okay. Depth of this, that's okay, and then I accept. So if I do a simulation, you'll see it does facing, rough turning, finishing, and then grooving. But I can put finishing the last point, for example, the last point. Yes, you see this is groove with the what? Groove with the chamfer. So I want to put this one, come here, cut, put the last one, paste, accept, so that the finishing comes the last. And then let's again do simulation. Why is it saying that there's no finishing? Why? Because this finishing goes the contour. So what you do, click on this one, mark with this one, and then copy, click here, paste, accept, and then remove for this one. So and then now it is okay. If you do like this, okay. Then from there we now put cutoff. Can pick the cutoff 0.8. That's okay. Where am I putting cutoff? It is 70. Diameter is 70. I'm going to, is it 70? Let me check. Diameter it is 70, yes. Then minus 70 also. Sorry, minus 70. It has a chamfer of 1. Let me put a chamfer of 1. 70, 35. Okay, that's okay. It's okay. Accept. So let's do a simulation. You see a simple program what they call ShopTurn. This is ShopTurn Programming. ShopTurn Programming. You'll see what it does. As you can see inside, yes, it's called ShopTurn Programming. And then from there, now finishing, then from there, part off. So you have your part. If you do 3D, you're able to see that this is now the part we have cut. This is the part we have cut. Very simple way of getting a program. Now I want to add something else here before cut off. I can come here on the stock removal for the finishing. I want to add, because I have a diameter 36, I want to add milling. So because this is turn mill, I want to add milling. So how do we do milling? For example, I can now go to milling. I want to put even a pocket, you see, or this rectangular pocket or circular pocket. Then graphic area, I want to put circular pocket or even rectangular pockets. Okay, no problem. And then I can come here, say the tool. I want to use Axial, centric. Make sure it's centric. I want to. It is only one point. The diameter that I want to put on this 36, I can put minus 20. Z to go inside the 15. That is minus 10. Then here I can go 5. Yes, this one change to absolute. The diameter is sorry, not minus, it should be positive. 10 days we go 5. Okay, I can just okay. Then you can do a simulation. We see how it will be doing now for milling, because this is now a turn mill. We're able to do turning at the same time we do milling before it does cut off. So we can do this part, we call it pocket on the face. You can see what the machine is doing now, pocketing on the face. Yes, pocketing on the face. This is how you can include various operations. I can also come on here and put another operation before cutoff, milling. I can say multi-edge. I can put multi-edge. I want to put maybe 6-sided on the front. Check on the front now, on the front, and then the diameter, for example, on this one, diameter is 36. We want to put here Z starting from 0 is okay. The length of this, let's say for example 12, it will be showing us. I can put even 20. We see how it behaves. I want to put this angle, graphic area, check that I want to put this angle 45, for example. You see how it behaves, or I can put it 30. You see, yeah, this is good now. This is good from graphic. I can now change here, and then radius are 2. Okay, this is minus 6. I can put minus 8 or minus 10. Okay, minus 10. This one I can put percentage. Let me put 40%. This one I can put, let it go depth of cut, I can put it is 10, I can put 5, it goes twice, then accept. Let's go and do a simulation. We see what will happen before it does cut off or part off. Let's see what will happen. Now let me put this side so that the people can see it well. So this now what you call mill turn. I'm doing turning at the same time I'm doing milling. That's why you see it's turning and then milling. So this mill turn. So this doing milling on the axial side. Then now malt edge on this. On this malt edge maybe smaller because I'm just putting this one for the sake. I can change this diameter, this length to be this maybe say 16, so it will be smaller a little bit. And then we do assimilation. You will see the difference. So this is what we call the mill turn programming on Siemens 840D controller. For those people who love using Siemens, like me, I love using Siemens controllers because they are user friendly and able to execute. Okay, let's see. Let's see now. You see? 2 times. Yes. This is how you able to create a program. You can put this is 18. Okay, radius of 5. Okay, accept, run. For the malt edge, sorry, I don't want to run it. I want to just simulate. So click here, reset button, then click simulate. Reset button again. Yeah, good. Reset button again. I put 3D. You can click here, reset button, and then exit from this command. Reset. Go to program. Then click simulate. So we only do simulation because I'm doing on my. I don't want to cut it fast forward because before you cut it, ensure that you do thorough simulation to check that whatever is cutting is right, and then also check the cutting parameters before you do a cut on your machine. As you can see now, what it's doing. Let's see. I can put the finish on the last line. It's no problem. Okay. Chamfer. Now go to milling. Goes to now axial milling. You see how it's rotating, and then from axial milling for pocketing now it does the Spigot. You see, Spigot. This is very easy. Yes, Spigot. On this Spigot we have chamfer. For example, I can copy, paste, change this to chamfer. If I have a chamfer tool, for example, here, let me check if I have a chamfer tool. I don't have a chamfer tool. So I'll go to offset and then ensure that I create a chamfer tool. Click on this one. They say new chamfer tool. Chamfer tool is like a center tool. So this is center tool, but on this side, and then this center tool, let's just check it as chamfer of 10, but axial, chamfer of 10, but axial. Diameter here is for this is 10. The diameter is 10. Number is okay, and check here, and then load to 18 tool. Go to program, click on here, change this one to chamfer tool number 18. Okay, don't worry that is for simulation because my magazine will only go for number 12, so don't worry with that. Then accept. Let's see how it will be doing the chamfer. Let's run a simulation. We see if it will do a chamfer or not. If it doesn't do, and then I'll show you how to do it. Maybe because I've not put the offset by Z, so I'll show you because I've done one was -8, so I'll offset my 0 point. Let's see. You see what it does? It has put a chamfer. So this chamfer, maybe you can change some parameters on this chamfer. sorry, the last operation is to be chamfer. So change this one now to chamfer, and then this one is chamfer of 0.5 on the 6th side. Okay, then do a simulation, you see, so we can offset it to -5. Then minimize for the sake of simulation. Put it somewhere here. You see, this is the then chamfer, but you see chamfer is doing on the starting point. So what you do, maybe you can offset our Z to, because it's going minus, let me check on this one to check to know the length I'm going inside. I'm going -10, so already it has cut 10, so I can offset here to Z -10. Okay, then let's do a simulation to see where the chamfer will cut. So this is how you can do a program. Remember, it was only for 2 axes, but I've added turn mill using ShopTurn, so that you're able to understand how you can change parameters, how you can add different operations for different program. And also remember this tool. This tool, the way it's approaching is too big. So when you're doing chamfer, you may be damaging the final part. So when you're putting a chamfer, ensure that you use the right tool or right diameter. For example, here maybe I'm using a very bigger tool for chamfer. I can say maybe my chamfer is 5. Yes, let me put my chamfer is 4, for example. I can change that to 4. Okay, and then go to program. From this chamfer, change the tool, number 18. Okay, accept, then do a simulation. You'll see what it tells you, that the chamfer tool, the insert section is too large. Yes, because it cannot enter, since this one I put a different I've changed this one, these parameters. So you see, anytime you change the tool, it may have different functions or effect on the program. So ensure that before you change the tool, make sure that all the parameters you are using are okay. For example, this one. Okay, then accept, do a simulation. You will see now what happened, because those diameters affect the output. So if you're doing a chamfer, ensure that you use the right tool each time. So as a programmer, these are the challenges you'll be experiencing, but as you advance your level, you will understand that these challenges are easier to handle, because already you understand the tool geometry, you understand the tool diameter, understand the contour where you are putting the chamfer. As you can see now, it has put the chamfer. But then if you're using the right tool, yes, if you're using the right tool for the chamfer mount, even maybe the chamfer mount is too big. Here, for example, I can even reduce it. Maybe I can put it, let's go to, let's say 1.5, so that it doesn't go deeper like that. Then I can put 0.35, so that it doesn't go deeper like that as we want. Then we use 0, so there's no 0 for that chamfer. Then we can do simulation again. We see, yes. So this is the beauty of Siemens. Before you run on the machine, each time you'll be taking a simulation to see the output. It's very important, so that before you put the program on the machine, this is what you do. Then I also want to show you easiest way of transferring program. What's the easiest way to transfer programs? What you do, input your USB to your computer, or for example, if you're using the simulators, put the flash on the simulators. Let's use USB disk. Once it reads, go to program manager, and then you see this flash. This is your USB. Now you can copy, you can minimize this one, then copy this one. For example, I can I can copy the program only. Let's say test1. Click here, copy, Then go to USB where you have your program. Maybe I can put here, let me put under precision because I have another folder here. On here, now click here, paste. This is the program that comes now on the USB. Now remove your USB. Then you see it doesn't read here. Take your USB now to your machine. Or you can use LAN cable. Or you can use your LAN cable to write your program. This is the what you call ShopTurn Programming. ShopTurn Programming, which I'm doing turning at the same time milling. Turning at the same time milling. In the next session, I'll show you how to do drilling. I'll show you how to do slot cutting, pocketing, threading, and engraving. Also using contour milling. All this in one program. Thank you for watching. Have a lovely day or lovely night.